Are you able to see my screen?
Yes, ma'am.
Yes, ma'am.
Yeah, okay, thank you. So these things only we have discussed in the last class, okay? Yeah, how it is transferred between the local area and back. And actually we have seen the write-text will not actually um, will make a write on the database, okay? Normally the write will held on some periodically, like we have will make the force output or something, so made to make the write happen. So that only we have seen how the data access is done with respect to the normal practical scenarios. Now we are going to see about the log based recovery. In log based recovery we seen about the log records, okay? So log is nothing but the series of records. Whenever there is an update in the database, that update activity will be noted down in the log. So it is a sequence of log records that maintains a record of update activities that are carried out in the database, okay? And we need to maintain the log in the stable storage. So we have actually three types of storage as we discussed, volatile, non-volatile, and one more storage we have introduced, that is the stable storage. Stable storage, we had an assumption that whatever the information we are storing in the stable storage, that will never lost, okay? So that using that mechanism only, this log based recovery schemes also work. So the recovery systems basically address the fourth property, durability property, even though if there is any failure after any kind of updates. So we need that kind of updates what we are making out in the database should persist, okay? So that is the main idea, okay? We have with respect to what durability property. So that is ensured by means of recovery systems, okay? So here the thing is, we maintain, if the log information in the stable storage only, we'll be able to withstand any kind of failures, okay? That is what we need to keep the log information in the stable storage, okay? Whatever the information we are storing in the log, that should never lose. So if the database recover from failure, it will see the, if there is any failure in the database, obviously it will see the log information, and then what are the changes that has been done, okay, before the failure, that will persist, okay? That will persist in the database through the log information. So that is the idea, okay? Basic idea behind this scheme. And for that, what we need to do is, we need to introduce certain records, okay? Whenever there is an update in the database, we need to introduce certain records, and that records need to be moved to the stable storage. So if the transaction has started the its operation, then we will include TI start, okay, which transfer for each and every transaction we will give some ID, and which transaction has started, that information we need to store in the log record. And whenever there is a write X operation, that is the update operation, then we need to perform, we need to just introduce some the log record with the old value and the new value, okay? So as I told in the last class, we have some modification, okay, with respect to the various scheme. Like in the deferred database modification, we use only the old value, and immediate database modification means we will use the old value and as well as the new value. So that are just given here as v1 and v2 respectively, okay? So this record we need to store in the log whenever there is an update in the database. Also, if the transaction has successfully finished its operation, then we need to introduce TI commit in the log record. And if the transaction has not successfully committed, okay, that is if there is intermediately any transaction failure, then obviously we need to store TI abort, okay, record in the log, okay? So these kind of log information will be very much helpful if there is if there is a failure in the database, okay? And definitely what all the transactions has updated the particular data items, and all those details will be there in the log, and from those information we'll be able to update the database. So that is what we do with respect to log based recovery. And we have two approaches, as I mentioned, deferred database modification and immediate database modification. So here in the deferred database modification, we also just term it out as redo. Okay, only redo will be that done. Okay, redo recovery, and here immediate database modification, undo and redo. Okay, so we had just term it out, okay, in a different manner, okay, for these two approaches like this. And now, first of all, we see about the deferred database modification. So in the deferred database modification, what it will do is, as the name implies, it will record all the database modifications in the log. Whatever the database modifications we have in the transaction, that will be recorded in the log, but it will defer the rights to perform after the commit operation of the transaction, after the partial commit of the transaction. So partially commits means it is nothing but the final action of the transaction is executed. Whenever the final action of the transaction is executed, so partially committed. So what we are going to do here is, we are going to defer the execution of all write operation until the transaction partially commits. So this is what we do with respect to deferred database modification. Okay, so here now here we have the assumption that the transaction is going to be executed serially, and we are not going to see about the algorithms that are used for concurrent execution of transaction. Only for serial order we are going to just to see how the deferred database modification can be performed. So if the transaction starts, then we write the record TI start into the log. Okay, and if there is a write X operation, then we include the transaction name followed by in which data item it is going to write the value, and what is the new value of the data item. Okay, so old value is not needed for this scheme, as I mentioned. Okay, only the new value is needed. Only this information is recorded in the log. Okay, so write is not performed whenever we just include the write operation. Rather, it will be deferred until the transaction partially commits. So when the transaction TA partially commits, we include the record TA commit into the log. Okay, so this is what we do with respect to deferred database modification. Okay, so first initially, whenever it starts its execution, TA start is added, and then there is a write, then and if the TA transaction partially commits, then we include TA commit, and if there is a write X operation, we include what is the new value of the corresponding data item in the log. Okay, so this is what we do with respect to deferred database modification. For example, consider these two transactions. Okay, and we are having T0 and T1 respectively, and those are executed serially. Okay, now what will be the log information for this transaction T0? What is the log information for this transaction T0? So for example, A, B, C values, let me assume that it is 1000, 2000 and 700 respectively. Okay, for these value, how the log record will look like?
First T1 start will come.
Okay, T0, right? T0 start. Okay.
Yes. T0 start will come, and after that T0 A and 950.
Oh,
Next
okay. Okay.
like that.
Yeah, that will be the record, and then
we have to write it. So I think write and all.
For each write we should have, okay, if it is on different data item, right? So again, write is there, right?
Yes, ma'am.
So for that,
I think you should commit partial commit or something.
so here write of A you have included. For write of B, what record we need to include?
Write of B we need to B record, ma'am. So
Yeah, T0 B, then
T0 B and 2050.
yeah. and partially committed. Okay, so we include T naught
Commit.
commit. Okay. So these are all the values. Okay, these are all the log records we will store in the log. Okay, with respect to the transaction T naught. Similarly, T1 we will have T1 start, then T1 C, and then 600, and then we have T1 commit. Okay. So these are all the log records we'll be having in the log. Okay. So now how the defer database modification can be used for recovering from the failure. Okay, that we can see. So here what how the log record will look like here is, as I have mentioned, okay, these are all the log, okay, we'll be having with respect to the transaction T0 and T1 respectively. And the database will look like this, okay, like until the transaction partially commits, okay, after that only we will make a modification in the database. Okay, A will the database will be updated to the value 950 and B will be updated to the value 2050. Okay, so this is what we do. Okay, so now how it is done. Now here there is one operation that we will use, okay, for the recovery from any kind of failure. So what operation we will use is the redo of TI. So redo operation, the purpose of this redo operation is it will set the value of all data items updated by the transaction TI to the new values. Okay. So what it will do is it will set the value of all the data items. Okay. All data items updated by transaction TI. Okay. By transaction TI to new values. Okay. So this only this operation will do. Okay. But one more thing we need to just see over the redo operation is the redo operation is idempotent. Idempotent in the sense executing it several times should be equivalent to executing it once. Okay. So the redo operation should be idempotent. That means executing it for several times should be equivalent to executing it once. Okay. So using this operation only, it will recover from failure for any kind of any kind of failure. Okay. So how it will do. Okay. So that we can see. Now here for this scenario, for the first case, you can see there is intermediately there is a failure, that is before T0 commit. Okay, before T0 commit, what it is done is here yeah, some failure has occurred. Okay, for some failure has occurred in the transaction, so there is no T0 commit. So here we are seeing the log record. We are able to see only the start of the transaction T0 and we are not able to see the T0 commit record. So with respect to this, okay, what decision we can make here is we can leave the database as it is because we haven't done any modification into the database until this time, right? Okay, once the database has partially commits only, so we will include the value in the commit record. Okay, once the commit record is there only, we will just update the database. Okay, we will update the database by means of redo operation. But here, since there is no commit record, only start record is there, we leave the database as it is. No redo actions are taken for this case, for the first case. Okay, for this first case. Okay. And for the second case, you can see, okay, the transaction T0 has performed perfectly. Okay, and we have some record that is missing in the transaction T1. So T1, there is no commit record. Okay, so there is no commit record. If both start and commit, both operations are there, okay, then we can perform the redo of T0. So then we can perform redo of T0. So which will update the database. Okay. So otherwise, if there is only start record and there is no commit record, we no need to do any kind of action. So T0 For transaction T0, we are performing redo of T0, and for transaction T1, nothing should be done. Okay. So for this case, the recovery mechanism will act like this. And for the third case, both transactions are having both a start and commit records. And if we see the both start and commit records, then we can perform redo of T0 and redo of T1. Okay. So that will update the database so that we'll be able to get the correct answer. So update the database every time. Okay. So are you able to get me? So this is what the deferred database modification will be done. So here, so what we are doing for each and every operation, update operation, we are storing the record in the log. And if there is any failure, then obviously we see the records only, okay, the log records. And if there is both start and commit for the particular transaction, then we will just redo the operation, okay, to just the value gets updated in the database, okay. Otherwise, if there is no commit record and only start record is there, then we will just neglect the corresponding operation. So how we will do with the new updated value? So obviously we'll be having the updated value in the log record, right? Okay, for each and every data item, we are having the updated value. So both start and commit operations are there. Then we will just update the data item to the new value. Okay. Otherwise, if there is no commit record, only start record is there, then we no need to do anything because it is not written to the database. Okay. So this is what we do with respect to deferred database modification. And there is one more log-based recovery scheme that is known as the immediate database modification. It is also called as undo redo modification. So this what it will do is it is somewhat different from the deferred database modification. So that is here it will allow the database updates of an uncommitted transaction to be made as the rights are issued. That is, whenever the transaction is in operation, that time itself it will make the database database updates, okay, for the uncommitted transaction also. Okay, so this is what the immediate database modification is done. So here we need to undo certain effects because before the transaction commits itself, we are going to update the database. Okay, if the transaction is not committing, okay, after that, then we need to undo the effect that is made to the database. So for that purpose only, we need to include both values. That is, we need to include the old value of the data item, and as well we need to include the new value of the data item. So both values we need to include, okay, in the log. So rather in the deferred, we make the modification once the transaction partially commits. Okay, almost it got entered into the end of the transaction. So that time only we are going to write. But here, whenever the write operation is done, okay, that is update is performed on the particular data item, then we will normally modify the data item in the actual database itself. Okay. So if it's so, then there should be a scenario to revert back. Okay, that is, if the transaction has not completed successfully, then we need to revert back to the old value. So for that, we need to store the old value of the data item also. Okay, so the update log record should be written before the database item is written. Okay, so that we need to ensure whatever the log record we are maintaining, okay, the old value and new value, before the database item is modified in the actual database, that this log record need to be written to the stable storage. Okay, so the log record, update log record, whenever it is to be written, okay, so we normally write the log record and then we will move on to the stable storage. Then after that only we will just make the modification in the database. Okay, then only if there is any failure, we'll be able to see the log record to retrieve those values. Okay. So like that we will do. So simply what we can do is we can extend to postpone the log record output so long as prior to execution of output of B operation, because output of B operation only, what it will do, it will make the actual database modification. So we will postpone this log record output to, that is, we will first of all we store the value of the log record in the stable storage, okay, and then we will just do the database modification. So the all records corresponding to items B must be flushed to the stable storage before outputting that same database modification by means of output of B operation. So that we will do. Okay. So these are all the things we need to do in prior for doing the immediate database modification. And how it will work. Okay, we can see the same set of transactions we can take over. That is the transaction T0 and T1. T1 is T0 is updating two items A and B. T1 is updating only a single item C. Okay. Now, with respect to this, the log records of immediate database modification will look like this. Like we need to, if the transaction commits, okay, we have the commit record. If it starts, we have the start record, and we are having the old value and the newer values of the data items. Okay, for each and every transaction. So this is what the log will look like. So now how we have the scenario for the immediate database modification is, you can see over here, that is we are immediately after doing the certain updates, okay, certain updates, we are writing the database, okay, writing the database. And here also you can see, okay, after modifying certain value of C, we are updating the database, okay. And we are updating the blocks also, so that may be different, okay, write operation may happen, but we are out when we output to the actual database, that may be different. Okay, here it is done before the commit operation of both the T0 and T1. Okay, so that we are doing with respect to BB and BC, and BA it is done after this. Okay, so like that this immediate database modification will be done. Okay, so actually like this scenario, okay, we will have the database itself, it is modified like this. So but the thing is we need to revert back if there is any failure. So we go for two operations, like we go for undo of transaction TI and redo of TI. So undo of TI, what it will do is it will restore the value of all data items updated by the transaction to their old value. Okay, so that is what the undo operation will be done, and the redo operation will set the value of all data items updated by TI to the new values. So this is what the two operations will do. And both operations, as we discussed in the before database modification, it should be idempotent. Even though if you are executing multiple times, the effect should be same. Okay, so that is what the idempotent just says. And for recovering after failure, okay, if the transaction, okay, for the same scenarios we can see the transaction T0 start we are having and there is no T0 commit. Okay, then what we need to do in case of immediate database modification? Any idea?
We should reverse all the changes.
Yeah. So we need to undo the effect, okay, because actually it has written the values to the database. So what we need to do is we need to revert it back. So for that we go for undo of T0. Okay, so that is okay. And similarly for this case, what we need to do?
Undo transaction on.
So we need to undo the transaction T1. Also, we need to redo the transaction T0. Okay. So why we go for this redo of T0? Okay, that is if the database itself fails. Okay, if there is a head crash or something, database itself fails, then obviously we will move on to the log-based recovery, and then only we have to do the operations, right? Whatever the transaction that has been committed, that will be known from the log records only. So for any kind of failures, what we do is if there is a start and commit record in immediate database modification, we redo the transaction. Okay, we redo the transaction T0, and since there is no commit record in the next transaction, that is T1, we will undo the effect. Okay, so we need to perform redo for the first transaction T0, and we need to perform undo for the second transaction T1. Okay, so this is what we do with respect to this scenario. And for this scenario,
We have to redo the transactions.
yeah, so we need to redo both transactions, redo T0 and redo T1. Okay, so like that, the immediate database modification recovery will work. Okay, so I think you got the idea how the recovery mechanisms are working, like deferred database modification and immediate database modification. So here this allows during the transaction in operation itself, the immediate database modification. So we go for two operations rather in the what refer database modification. Only one operation is needed, that is redo of the transaction, the corresponding transaction, and we have seen the various scenarios, okay, that are applied in both cases. Okay, so this is all about the log based recovery schemes. Okay, log based recovery schemes, the immediate and as well as the deferred database modification. Now here think, so checkpoints also there. Okay, so during recovery, okay, we can also consider only the most recent transaction. Okay, so yeah, so here the thing is problems what we have discussed in the log based recovery scheme, it is actually very time consuming. Okay, so that is we need to unnecessarily redo transaction. Okay, so because if there is no database modification, okay, if there is no database failures, okay, simply what we are doing, okay, even though if there is a transaction failure, we are redoing the operations, right? Okay, so as we have discussed in the last two modification log based recovery schemes, so we go for unnecessarily we need to redo the transaction which has already output their updates to the database. So for that we have streamlined the recovery procedure by periodically performing some checkpointing. Okay, so here what it will do is it will output all the log records currently residing in the main memory onto the stable storage. So that is a normal procedure. And also what it will do is it will output all modified buffer blocks, okay, to the disk, and it will insert a log record checkpoint onto the stable storage. Whenever it has inserted all the modified buffer blocks to the disk, then it will insert a log record, that is the checkpoint onto the stable storage. So first of all, it will just update the log record into the log stable storage. And once the modified buffer blocks, okay, that is in the main memory, we have updated the contents into the disk, it will write a log record, that is the checkpoint onto the stable storage. So when it will be useful is rather than going for all the transaction that has happened in the log. So suppose there are 10 transactions, okay, T1 to T10, okay, T1 to T10. So here rather than checking out all the transaction and then redoing, undoing and all those things to happen, rather what we are just doing here is any kind of buffer blocks, okay, that is previously, that is between the checkpoints, okay, between the checkpoints we will just check it out. Okay, so suppose T1 to T5 it is modified and we have added a checkpoint over here, so there is no need of going for beyond checking T5 to T1 again. Okay, if there is any kind of failure from T6 to T10 only, we can see the log record, and if there is any modification we can just go for updating the database. So for that purpose only the checkpoint is useful. Okay, so for the particular point, until the particular point on which we need to see the database to the consistent state, because already if we have done certain things and all the things are being normal, no need to go beyond that. Okay, so for that only the checkpointers points are useful. So there are procedures for Yeah, any kind of checkpoints. Okay, so during recovery, what we need to do here is we need to consider only the most recent transaction TI that started before the checkpoint. Okay, and transaction that started after the TI, that only we need to check. Okay, so that is what I have told. So no need to check entirely what all the transaction that has been executed. Rather, we can just choose the transaction only before the checkpoint, that before starting that before the checkpoint, whatever the transaction that has started, and the transaction that started after the transaction TI. So those transaction only we have to consider. Okay, so for that what we need to do is we need to scan the log. We need to scan the log backwards from the end of the log to find the most recent checkpoint record. So where the checkpoint record is there, and we need to continue scan backwards. Okay, we need to continue the scanning backwards till a corresponding transaction has started its execution. Okay, so whatever the transaction has started its execution, so still that we need to scan backward. Okay, after that what are all the other transaction from that transaction we need to consider. Okay, so that is what the checkpoint will be used. So no need only to consider the part of log following above that start record. Okay, we can earlier part of the log we can ignore. Okay, we can ignore, and we can even erase it. Okay, erase it during, because if we are going keep on storing more and more information in the log will storage will be very much huge. Okay, so rather we can erase entire thing whatever it is needed, and we can start from this itself. Okay, and for all the transactions starting from TA or later. Okay, with if there is no commit, okay, we will execute undo of TI. Okay, so that is, it uses the immediate database scheme. Okay, so it will utilize, it will execute the undo of TI. Okay, it is done only in the case of immediate modification. Okay, and after that we will scan forward in the log for all the transactions starting from TI or later with the TI commit. Then what it will do is we will execute redo of TI. Okay, so this is what the procedure is by means of checkpoint. So for example, if you are seeing this case, yeah, this transaction, totally there are 4 transactions, T1, T2, T3 and T4. Okay, we are having, and here you can see the first transaction, because this is the checkpoint we are having. Okay, which transaction we can ignore here is the transaction T1, because we need to know what are all the transaction immediately started before the checkpoint. From that transaction, what are all the other transactions we are having in forward, that only we need to consider. So totally what we need to consider here is only the transaction T2, T3 and T4. Okay, so now T2 has started just before the checkpoint. Okay, so T1 we no need to consider. Either we can erase the log records of T1. Okay, so T2 if we are considering, then T2 and T3 if we see. Okay, T1 can be ignored, and T2 and T3 we are having. Okay, so this is having the start and end point. Okay, so start and end point both we are having. So, and also you can see T3 also having start and end. Okay, start and commit record. Here only start is there and there is no commit. Okay, in T4. So what we need to do here is T2 and T3 both can be redone and T4 should be undone. Okay, so this is what the procedure we follow for using the checkpoints. Okay, T1 can be ignored, T2 and T3 should be redone, and T4 should be undone. Okay, so this is the example of checkpoint, and there is some procedure for recovery with concurrent transactions also. Okay, and here the thing is, yeah, here multiple transaction. Okay, all the schemes what we have discussed in log based recovery, deferred or immediate, and as well as right now with respect to checkpoints. Okay, we consider only the transactions are executed serially. You can see T1 to T4 executed serially, but if we are going for concurrent execution of transaction, then how the recovery will be done. Okay, so here all the transaction will be sharing the single disk buffer and a single log only. Okay, so a buffer block can have data items updated by one or more transaction. Okay, a single buffer block can have data item updated by one or more transaction because it is the transactions are executed concurrently. Okay, so here the strict two-phase locking is used, in which we just follow a recoverable schedule and a cascadeless schedule. So here the update is of uncommitted transaction should not be visible to other transaction. Okay, strict two-phase locking means what we are doing until the transaction commits, the lock will be held by the exclusive mode lock will be held by the particular transaction. So that we just maintain over here, okay, in the execution of concurrent transaction, because concurrent transaction, if we go for, we need to go for any kind of concurrency control schemes like locking protocols or timestamp based protocol. Here we are assuming it is a strict two-phase locking protocol. So strict two-phase locking protocol, what it is insisted here is the right operation, if the exclusive mode, all the exclusive mode locks are held until the transaction commits. Okay, so for that, so here this is more important because we cannot undo if some updates, T1 updates A and T2 updates A and committed, and finally T1 has to abort. Okay, so T2 has committed. Okay, T1 has updated something. Okay, and there are dependent transaction, and the dependent transaction has committed means how we can what undo the effect of the other transaction. So we cannot abort the transaction. Okay, right? So that is what we prefer going for strict two-phase locking protocol. So log records, as we described, that is done, and how the checkpointing technique is useful. Okay, that we can see over here. So here during the normal operation logging, we have all the records like this. Okay, what we have discussed, like TA start and old new values, TA commit. Okay, and during normal operation, the transaction rollback, okay, will be held. Okay, so here here if you want to scan the log backwards from the end, and if there is any data, if there is any failure, okay, there is no commit record, then normally we undo it by writing the old value to the data item. Okay, so and here and obviously we just after writing that, okay, after writing that, what we will do is we will write a log record like this. Okay, write a log record like this, which transaction we have performed the undo operation. Okay, so those information also we will just include in the log record. Okay, so this is what we do with respect to any kind of transaction rollback. So if there is no commit record, we need to undo the effect. After undoing the effect, we will include this record. Okay, this log record is also called as compensation log records. Okay, what value we have assigned, okay, for the value of the data item X, okay, XJ. So that we need to know. So that log record also will be inserted, okay, during the transaction rollback. Okay, so here we once the record TA start is found, so we need to stop the scan until what we need to scan, and then we write the log record TA abort. Okay, so this is what we do with respect to the transaction rollback. So here, because we are performing the rollback operation, right? We need to abort the transaction. So for that, we include the TI abort in the log record also. So this is what we do with respect to transaction rollback, and this is log information during any kind of normal operation. For if there is any rollback, we will include the log record on which value, that is the earlier value, what value we have updated, and we have to include the abort record also. Okay, so this we do. And recovery from failure, okay, it involve two phases. Okay, what it will involve is that is the redo phase and the undo phase we have. In the redo phase, we just replay the updates of all transaction, whether they have been committed, aborted, okay, or incomplete. Okay, so that information, okay, we will just gather and we will do. And here undo phase, we will do undo all the incomplete transaction. Okay, so here yeah, so these are all the two phases we have. We can see the each and every phases in detail. So here redo phase, what we will do is we will find the last checkpoint L record. Okay, what are all the which we need to find out the list of transaction. Okay, list of transaction record. Okay, and we set the undo list to L. Initially we set the undo list to this list of transaction L. Okay, so from this checkpoint we will scan forward from above the checkpoint L record. Okay, and if there is any record like this, okay, the transaction or any record like this, only the new value, okay, it is found. If there is immediate or deferred database modification, based on that the record will vary. Okay, so here if it is found, then we will redo the values by writing the value of v2 to xj. Okay, so that we will do. And whenever a log record TI start is found, then we will add the transaction TI to undo list. Okay, so here the transaction TI start is found. Okay, whenever a log record TI start is found, we will add the transaction to the undo list. And finally, if we have TI commit or TI abort is found, we will remove the transaction from the undo list. Okay, so here what we are going to do is, first initially checkpoint L is nothing but the list of transaction that is initially we have from the checkpoint. Okay, so initially it will set the undo list to the initial set of transaction, and if only TS start is found, okay, then we will include the corresponding transaction to the undo list. Okay, so if we just have TA commit and TA abort, okay, because we know here the transaction has successfully completed or the transaction failure has occurred. For both the cases, we have TA commit or TA abort record in the log. So what we need to do is we need to remove the corresponding transaction from the undo list. Okay. First, we need to create an undo list. For that only, in this phase, we are doing certain operation. So once it is done, the undo phase will contain the list of transactions that need to be undone. Okay. So here, what we will do is we will scan the log backwards from the end. Okay. Here we will just scan the from above the checkpoint L. Okay, like before in the singles transaction, we will check just scan forward from above the checkpoint L record, and we will scan. Okay, and we just include certain set of transaction into the undo list. Okay, that we will do in the redo phase. Once it is done in the undo phase, we need to do some undo operation. How it is done? We again check this log record from the end backward, okay, to the checkpoint L. Okay, so for that, whenever a log record, this updation record is found. Okay, so and TA record, okay, TA transaction is in the undo list what we have created. Okay, so here we need to perform the same actions what we have done with respect to transaction rollback. That is, we perform undo by writing the value of v1 to xj, and we will insert the log record, compensation log record, okay, as we have discussed. So that we will include in the log record. Okay, but if here whenever a log record TA start is found and TA is in undo list. Okay, TA start is only found and TA is in undo list. Okay, and what we do is we will write a log record TA abort. Okay, abort, we will just make it out because there is only TA start and there is no TA commit. So we will write a log record TA abort, and we will remove the transaction TA from the undo list. Okay, so we will need to perform these operations. Okay, undo until the undo list is empty. Okay, so this is what we do with respect to the undo phase. So here after the undo phase completion, undo phase completes, the normal transaction processing can be done. Okay, so now we can see with respect to this operation, okay, this example of recovery. So there are some certain records, okay, which involves transaction T0, T1 and T2. Okay, and there is some crash. Okay, after this T0 abort, we are having a crash. Okay, so now with respect to the algorithm, the redo pass will start from the checkpoint. Okay, checkpoint L will have the list of transactions, okay, that has been that is earlierly started. Okay, so here you can see T0 and T1 has started early, so that list already we have, and we need to include as much of transactions, okay, in the undo list. Also, if possible, we need to remove from the list also. Initially, the undo list will have T0, T1, okay. And we from in first initially we start from the checkpoint, that is the redo pass. Okay, redo pass we will have. So for that, what we will check it over here is in the redo pass. Here, whenever a record, this one found, okay, that is update record is found, we will redo it, okay. And also, whenever a log record TI start is found, we will include in the undo list. And if we have commit and abort, then we remove from the undo list, okay. So here you can see T0 start is there, okay, and T0 abort is there, okay, T0 abort is there. So the rollback has been already completed. So we can remove the corresponding record. Remove the complete record. Remove the record. Okay. And then if we see T1 start, okay, so there is no T1 commit is also there. Okay, so we can remove from the undo list. And after that, we can see there is an update record, okay, that is with respect to T2, and only T2 start is there. So the condition for redo phase is if whenever a log record T start is found, we have to add the TI to the undo list, okay. So the only transaction we have in the undo list is T2. So T0 and T1 either has committed or aborted in the earlier cases. So the rollback here is completed. Okay, already this is a compensation record corresponding to T0 with respect to rollback. T0 B 2000 is nothing but the earlier value. So rollback has been completed, and then we have included the T0 abort. Okay, include T0 rollback has been completed. So T2 is in incomplete at crash. So only transaction we have with respect to this undo list is T2. Okay. So once we have got the undo list, okay, undo list in the with respect to the recovery scheme, we go for undo pass. Okay. So that undo pass will just start from the end of the transaction. And it will move backward. Okay. So here what we have is T2 the end of the transaction. What we have, okay, we need to perform the undo pass. Okay, what it will do is it will start the log records found for all transaction in the undo list. So here undo pass, we need to undo the effect of the transaction T2. How it will be done? So it is similar to the rollback. Okay, this is what the first case what we have described, that is the transaction rollback what we have done. So such same procedure we need to follow for undoing the effect of the transaction. What we are doing here earlier for this A value, what is the old value, that value will be added as the compensation log record. Okay, compensation log record, and then we need to abort the transaction. So the first scenario what we have, okay, so we have to perform undo by writing the old value to the data item, and we need to write the log record. Okay, so here whenever we just log record TI start is found, and TI is in undo list, and the second thing what we need to do is we need to write the log record TI abort. That is what the second second record is inserted in the log. Okay, for this undo pass. Okay, so T2 abort is inserted. Okay, until the undo list is empty, we need to do the operation. So here only T2 is there, and we have inserted the compensation and as well as the abort record in the log record. So this procedure has been completed. Okay, so this is what we do with respect to the recovery with respect to multiple transactions that are running at the current concurrent transaction executed at a particular time. So this is what the recovery algorithm works. Okay, so one more procedure is there, that is the shadow paging. So that we can discuss in the next class. Okay, students. Yeah, so we can discuss about the other recovery procedure in the next class. Okay, thank you.
Okay, ma'am. Regarding this,
regarding
like it was echoing.
what? I'm not able to hear.
Regarding this weekend, the programming assignment, ma'am.
It is not programming assignment. Okay, it is a numerical problems only. So we'll be having 10 questions, 2 marks each. Okay, and I'll be just sharing the forms too. Okay, and you have to submit the detailed answers for that corresponding questions. Okay, and with the time duration is 1 hour, 3:30 to 4:30.
Forms, there
Yeah.
will be 10 questions. Okay, ma'am. So
10
forms
questions
mean,
you need to submit. The multiple choice will be there.
so for to give descriptive answer, like numerical problem, like you want to solve the problem, ma'am. So that
Yeah,
answer
you
we
have
should
to
upload
solve the
as a
problem.
PDF.
Yeah, yeah.
So multiple choices also will be there, and finally we have to upload an PDF.
Upload also. Yeah.
Okay.
Okay. So the duration is 1 hour, 3:30 to 4:30. Okay. Any
Yes,
other
ma'am.
doubts? Yeah. Okay, fine. Okay. So please prepare for the assignment also. The 4 units, okay, will be having as the portion. And yeah, as I told, 10 question, 2 marks each. And you have to submit the form as well. You have to upload the answer sheets. The detailed answers, how you arrived at the solution, that also it is needed. Okay. So you upload on proper time. Okay. Penalty will be there. Okay. If you are extending some more time to upload or something. Okay. So that will be there. So upload at the proper time.
Will we get some uploading time also, ma'am?
What?
We will get some uploading time also, right, ma'am?
Uploading time is needed.
Ma'am,
That's
for form that don't needn't be like extra time, ma'am.
so
Uploading
10
and
minutes, 10 minutes I can give more than. Huh?
yes, ma'am.
Okay. So 1 hour, 10 minutes. Okay. For uploading the answer sheets. Form, it will be 1 hour only. Okay.
Okay.
Okay. Okay. Okay, students. Thank you. Thank you very much. Okay.
Thank
Now
you.
we can see in the next class.
Thank you, ma'am.
Yeah. Yeah. Thank you.